Hello again. Today we're going to do chapter 12.1, which talks about integers as exponents. So pretty much this chapter has a lot of rules in it. They're very nice. You can usually extrapolate them from writing out what exponents really mean. And what I mean by that is if we have 2 cubed, for example, what that really means is 2 times 2 times 2. And if we write out what it means, we can gather a lot of these rules, like the first 2 I have listed here. X to the first equals x, and x to the 0 equals 1. So what I'm going to do is kind of derive these rules. So I know 2 cubed means 2 times itself 3 times. And if I were to write out what 2 squared means, I have 2 times 2. So I have it twice. Pretty much I dropped a 2 and I dropped a degree in the exponent. Kind of like if I divided by 2 on one side, I got rid of it, and I divided 2 on the other side, and I went down a degree. And I could do the same thing. If I were to divide by another 2, now I have 2 to the first, so that means I should only have 1 2 times itself, which is 2. So there is our first rule. Now the next rule comes a little bit more harder for most students. Notice we kept dropping off a 2, so to speak. We've been dividing out a 2. So each time we divide by 2, we drop down a degree. So we drop down another degree, so we have no 2's left. And what is 2 divided by 2? 1. There's no 2's, so that's what that 0 is meaning for the degree, and it gets us 1. So anything to the 0 is 1. Now we're going to go ahead and tackle some more problems. So here's another rule. We have x to a power times x to another power equals x to the powers added to one another. Now be very careful. Notice we have x and x. We're multiplying the same base, and then we add the exponents. So if we were to have something like 2 squared times 2 cubed, what we could do is we can write out what this really means. So what it really means, 2 squared means we have 2 times 2, and 2 cubed means we have 2 times 2 times 2. And now you can count out how many 2's. We got 1, 2, 3, 4, 5. So this means we have 2 to the 5th. And we could even do that. What is 2 plus 3? Well, it's 5. So it's nice. We can even do it with variables. Let's say we have x squared times x cubed. Well, we can write out what it really means. X squared really means we have x times x. X cubed really means we have x times x times x. Now we can count up how many x's are there, and there's 5 once again, because 2 plus 3 is 5, and we have x to the 5th. So that is when the bases are the same and we multiply. So we add the exponents. Now let's see if we were to divide. If we divide and the bases are the same, notice they're both x's, then we subtract the exponents. So we'll start off with our nice example. Let's say we have 2 to the 10th over 2 to the 4th. So let's write out what this really means. We have 2 times 2 times 2. Maybe I shouldn't have picked 10. It's a really big number. But we'll write out it 10 times, right? Let's torture ourselves for one good time. Let's see. 1, 2, 3, 4, 5. I need one more 2. There we go. So there's 10 2's all over, 4 2's. Now, if you remember, back in the good old days, we had a nice rule. If we had the same thing divided by itself, that equals 1. So, let's see. I have a 2 up top and a 2 in the bottom. 2 divided by 2 is 1, and 1 times anything is the same thing. So that's nice. Alright, let's look at another one. Here's a 2, and here's another 2. Just as long as we don't double dip our 2's, then we're safe. Only use them once. Maybe I don't like this 2, and he'll cancel out with there. Now, I need to count how many 2's are left. I got 1, 2, 3, 4, 5, 6. So I have 2 to the 6. And let's see if that follows. What's 10 minus 4? 6. Beautiful. And you can do the same thing with variables. Let's say we have x to the 10th over x to the 4th. Well, 10 minus 4 is what we'll do, and that is 6. Now be careful. The bases have to be the same. If by some chance, and I'm going to squeeze this on here on the page, I had x to the 10th over y to the 4th, are the bases the same? No. So I can't simplify it any further. That's it. That's my answer. So make sure you check that the bases are the same. Now this brings up an interesting question. What if we have a negative result? Well, when that happens, we don't like negative exponents. So if we have x raised to a negative power, we can make it positive by bringing it down into the denominator. Or vice versa. If we have a negative power in the denominator, we can make it positive by bringing it up to the numerator. So let's see a nice example in which we have to make the exponents positive. Let's say we have x to the negative 10th. And we want to make it positive. So we'll write that as 1 over x to the 10th. And this is the more correct way to write our answer. Same deal if we had a negative exponent in the bottom. Let's say 1 over y to the negative 2nd. We can make it positive by bringing it up top, and we'll have y squared. The next rule we have is a power raised to a power. Now, what I'm going to do here is write off nice example. Let's say we have 2 cubed, and then we square it. So what I try to do is I try to blank out what's inside the parentheses. So what have I done? Square, blank it. That didn't work at all. Let me fill it. Let's see if I can do this before, or is it not worth the effort? No, it's not worth the effort. All right, pretend you can't see this 2 cubed. You have something squared. Oh, I'm still on the stupid thing. We have something squared. So that really means we have whatever that something is twice, times itself. We so happen to have 2 cubed. So that means we have 2 cubed times 2 cubed. Now we're multiplying these two. It's 2 cubed times 2 cubed, and they have the same base. So same base, we add the exponents. 3 plus 3 is 6. And we can see 3 times 2 gets us the 6. So when we have a power raised to another power, we multiply the exponents. It's very nice. Let's do one more, only because I made so many boo-boos. Let's say we have x to the 5th raised to the, I don't know, negative 6. It would be crazy. Well, we have a problem here because it is raised to negative 6, but if we have a power raised to a power, we are going to multiply them. So 5 times negative 6 is negative 30. And then we don't like negative exponents, so we have one more rule we're going to use where we make it positive. So our answer is 1 over x to the 30th. So we can use the rules simultaneously. It's very nice. In fact, let's see this rule one more time a little bit different. We have x times y raised to the power n. Now, it's a multiplication going on inside the exponents. So we don't have to worry about order of operations too much because exponents is repeated multiplication. So everything's being multiplied. We're very happy. And it's all raised to the power n. So let's see. We could have, I don't know, xy raised to the 3rd power. So what that means is we have that something in the parentheses times itself 3 times. And it so happens we have x times y, x times y, x times y, all multiplied together. Now I write the parentheses to emphasize what it really means, but they're not really necessary because all this represents is multiplication. And by commutative law, it doesn't matter the order we multiply in. So we can switch stuff around. I'm going to rewrite this, and if you need to stop and think about it, do so. Where I multiply all my x's together and then all my y's together. Because I'm kind of keeping like terms together, so to speak. Same variables with the same variables. Apples with apples, bananas with bananas. Now I have x times x times x. That's really x cubed. And then we have y times y times y, which is really y cubed as well. So you could kind of see we took this 3, so to speak, and distributed to each exponent. So just like the n here, it went to each one. That's what occurred. So here's our answer. Let's see this one a little bit different. We have x raised to a power a and y raised to a power b, and then all of that in parentheses raised to the power n. And it kind of follows suit the same thing, where we take that n and we distribute it to each one, and then we multiply them. So let's see what's going on here. We have x squared, y cubed, all of that raised to, I'll pick a nice number, 4. So if we wanted to write out what this really means, all right, we have x squared, y cubed times x squared, y cubed, and repeat that 4 times, right? And last one, x squared, y cubed. Now, going on here is all multiplication, so it doesn't matter what order we multiply in. Since in order for us to combine anything, they have to have the same base. I'm going to write all my x's in the front. They're all being multiplied together. And we'll write all our y's together. And be patient. I picked, I guess, a pretty big number. So there we are. Now let's see. I have 4 of these x squareds, which if you were crazy enough, you could think of as x squared raised to the 4th, right? In which you could just add all the exponents, or you can do 2 times 4. Either way you do it, you end up with x to the 8th, right? 2 plus 2 is 4, plus 2 is 6, plus another 2 is 8, or 2 times 4 is 8. Whatever way you want to think about it. Same deal with the y cubes. We have y cubed raised to the 4th. So we could do 3 times 4 is 12, or 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12. And we got the same answer. So we could take this 4 here and distribute it to each one. We'll do 2 times 4 is 8, 3 times 4 is 12, and there's our rule. So you can see you don't have to have these rules memorized. You can always write out what they really mean. The only time it's useful to have them memorized is when the numbers get ridiculously large. Like, I had it to the 4th power, and that was actually a little bit of a pain to write out. When you have it to the 10th or to the 20th, then you get like, ugh, the numbers are too big. So the rules are nice there. But you can always start small. Now this is for multiplication. Let's see what happens with division raised to a power. So they say if x divided by y is in parentheses, all raised to the m, you can take that m and distribute it to both the top and the bottom. So let's see it a little bit nicer. Let's say we have x over y, all of that squared. Well, what that really means is x over y times x over y. And when we multiply fractions, we multiply straight across. So we have x times x up top and y times y in the bottom. X times x is really x squared, and y times y is really y squared. So there's your rule. Very nice and very pretty. And we can pretty much add in more exponents into it. We have x raised to the a, y raised to the b, all of that raised to the m. You can distribute the m to each one. And then when we have a power raised to a power, we multiply. So let's use this rule. We have x to the 5th over y to the 7th. All of that raised to, and let's be horrible, the 10th. So you can write out what this really means, or you can use the beauty of this rule where we have x to the 5 times 10 over y to the 7 times 10. 5 times 10 is 50, so you could write out x 50 times, that would be a pain. Or you got y to the 7th times 10, which is y to the 70th. And there's your answer. So either you remember what they mean and you write them out. You can always start with small numbers so you can derive your formulas, or you memorize these. It's up to you how you want to do it. And that's all.